This is going to be a very full-fledged video covering many topics like Macaulay duration, Macaulay duration, modified duration, modified duration. Then it will cover effective duration, effective duration. Then convexity, convexity. Then money duration, money duration, money convexity, money convexity. Then change in bond price, change in bond price. Using the same example, I'm going to do this. I'm going to find out all this terms: Macaulay duration, modified duration, effective duration, convexity, money duration, money convexity, and change in bond price. So using the same sum I'm going to do, I will also cover convexity based on cash flows as well. Convexity based on cash flows. So this is going to be a big video, but then I'll just try to cover it as quickly as possible. But then you will be able to get a clear picture of all these terms, as I'm going to use only one sum or only one question. From the same question I'm going to solve all this. Okay, so number one, Macaulay duration. So Macaulay duration is the weighted average number of years that an investor will have to wait if all the amount is paid to him in one go, in one shot. If he receives the payment, what is the average time that he has to wait? That is Macaulay duration. Okay, so let's do this with the sum 5-year bond. Let's say this is the sum I'm going to keep as the base for finding all other sums as well, or for other terms as well. Okay, so 5-year bond coupon is equal to 11 percentage, market rate is 15 percentage, IY interest per year is 15 percentage, future value is 100. Okay, and so you can find out the present value. Present value will come to 86.59. So now I'm supposed to find out Macaulay duration. So Macaulay duration is equal to it is present value of individual cash flow, okay, divided by present value of total cash flow into number of periods of payment, number of periods of payment. Okay, so what this formula means, this is these words are mine only. I prefer writing like this, but then I'll explain it to you and then you will be able to understand this. See, so let me draw the timeline first of all. So this is for 5 years. So 0, 1, 2, 3, 4, and then 5. Okay, and coupon is 11 percentage. So 11, 11, 11, 11, 11, and then 100, the par value we will get back. Now I'm supposed to find out present value of individual cash flows. So individual as in first one. So I will discount it with the current, I'll discount it with the IY, that is 15 percentage. So first one, So first one comes to 9.56. Okay, so 9.56, this is the first one. So I'll just calculate all the present values first. So this is 8.31. Okay, this is 8.31. Now the third one, this comes to 7.23. The fourth one, 6.28. And the fifth one is 111, this one. So accordingly I need to calculate. So that comes to 55.18. So I'll add up all this. So 86.59. This is the total value. Total value is 86.59. So now, as per the formula that I have given here, present value of individual cash flow. So Macaulay duration is equal to present value of individual cash flow. So individual, first one is 9.56 divided by present value of total cash flow into number of periods of payment. So total cash flow is 86.59 into number of periods of payment. This is the first period of payment. So that comes to 9.56 divided by 86.59. So 0.11. Then the second one is 8.31. So 8.31 divided by total value 86.59 into second period of payment. So that comes to 0.19. Then third one, 7.23 divided by 86.59 into third period of payment. So that comes to 0.25. Now fourth one is 6.28. So 6.28 divided by 86.59 into 4. 6.28 divided by 86.59 into 4. So that comes to 0.29. And the last one, 55. This one is 55. So 55.18 divided by 86.59 into 5. Okay. 55.18 divided by 86.59 into 5. So that comes to 3.18. Now if I add all this, it comes to 4.03. So Macaulay duration is equal to 4.03. It should be suffixed with years because this is the weighted average period of time one will have to wait if they want to receive all the payment in one go. Okay, so that's why it is suffixed with years. Now, duration point of view, duration refers to the sensitivity of the bond price for 1% change in the interest rate. Okay, so the sensitivity point of view, if this amount is paid in one shot, 4.3 years. Now, if the interest rate changes by 1%, then for 4.3 years it will change by 4.3 percentage. Fine, 4.3 percentage, that will be the sensitivity or the duration. Now, if I want to find out modified duration, it will be uh, Macaulay duration divided by 1 plus YTM. So 1 plus YTM is the present value. So 4.03. So this is 4.03. Sorry, this is 4.03. So 4.03 divided by 1 plus YTM was 15 percentage. So that comes to 3.5. Okay, it comes to 3.5. So modified duration is the present value. Okay, so overall 4.03 percentage, which is whose present value is 3.5. Okay, so this is modified duration. Then the next one, effective duration. Okay, effective duration will also give me the same result, 3.5. Okay, it will give me the same result of 3.5. Let's just cross check that one. The formula for effective duration is equal to V minus V, as in value when the interest rate comes down, that's why minus value when the interest rate goes up, that's why plus, divided by 2 V0. V0 is present value into delta YTM. Okay, so change in the interest rates. So now I am just rewriting this question again. Okay, so here 5-year bond, coupon is equal to 11 percentage, IY 15 percentage, future value 100, and present value is equal to 86.59. Now imagine if because I need to know the change in interest rates. Okay, now the change in interest rate, let's say in this question there is a change of 50 basis point. So change of 50 basis points. 50 basis points means 0.5 percentage. So in this case, how will I find out the effective duration when the change of 50 basis point happens for this question, for this given condition? Okay, so now change as in it may go up or it may go down. First I will check if it goes down. So if it goes down, new IY will be 14.50 percentage. So rest all remains the same. 5-year bond, coupon 11 percentage. Now IY is 14.5. Future value is 100. So in this case, present value will be, so if you calculate, it will come to 88.127. Similarly, here the new IY will be, if the interest rate goes up, it will be 15.50, correct? Because right now it is 15 and it is going up by 0.5 percentage, so 15.50. And so rest all remains the same. 5-year bond, coupon 11 percentage, future value 100. So here present value is equal to 85.092. Okay, so this I can consider as V minus. When the interest rate comes down, this is the value, and this is V plus. When the interest rate goes up, this is the value, and this is V0. Okay, this is the current price. So based on this, and this is 0.5 percentage, that is equal to 0.005. Okay, 0.5 percentage is equal to 0.005. So based on this, I'll just key in all the numbers in the formula. So effective duration is equal to uh, so V minus is 88.127 minus V plus is 85.092. Okay, so here it is, this one, and this number is here, and then divided by 2 into V0 is here 86.59 into 0.005 delta YTM, which we discussed here. Okay, so if I calculate all this, the numerator will come as 88.127 minus 85.092, so 3.035. Okay, denominator is 2 into 86.59 into 0.005, that comes as 0.8659. So when I calculate, I will get this as 3.5, which matches with modified duration. Okay, yeah, so that is effective duration. Okay, then comes convexity. Okay, so convexity, next one, convexity. So convexity is equal to, convexity is the curvature of the price because of the change in the interest rate. So the formula is V minus plus V plus, okay, then minus 2V0 divided by V0 into delta YTM square. Okay, so V minus, we already know the value. V minus is 88.127. So 88.127 plus V plus is 85.092. 85.092 minus 2 V0 is 86.59. 86.59 divided by 86.59 into, now because this is the second derivative, that's the reason why we are squaring it up. Okay, this is the second derivative. Okay, because first one is a duration and then convexity, so that's why it is the second derivative. So here 0.005 square. So if you calculate all this, it will come to 16.916. Okay, 16.916. Now this I can cross check in another way as well. Another way is, so another way is convexity based on cash flows. That means individual. So I'm going to break down this number. Okay, so based on each cash flow I'm going to find out, which is called convexity based on cash flow. So convexity based on cash flow, here the formula will be T into T plus 1. T is the time period, divided by 1 plus R raised to 2. R is the YTM. Okay, here R is the YTM, and you have to multiply with the weight. What is that weight? I will let you know. Okay, so this is the formula. Now again I'll just write the cash flow: 0, 1, 2, 3, 4, 5, and it is 11, 11, 11, 11, 11, and 100. It's the same sum, right? And that's why same cash flow. Okay, so uh, yeah, 1 plus this is 15 percentage raised to 1. uh, Similarly, this is second one, third one, fourth one, and fifth one. uh, so, so first one, I should just copy paste this same number: 9.26 sorry 9.56, 8.31. So I'll write down all this. It is 9.56, 8.31, 7.23, 8.31, 7.23. Okay, 6.28, 55.18, 6.28, 55.18. Okay, so now uh, yeah, so now first one, so convexity based on cash flow. So convexity based on cash flow. So the formula I said T into T plus 1 divided by 1 plus R or else YTM square into weight. That weight is the cash flows weight. Okay, say for example, uh, let's say uh, so for the first one, T is first period, so first period of payment. So T1 plus 1 divided by 1 plus R is 15 percentage YTM square. Okay, into weight will be weight is going to be this 9.56 out of what was the total cash, 86.59, correct? If you add up all this, it comes to 86.59. So it will be 9.59 divided by 86.59. Okay, so that comes as 1 into 2 divided by 1.15 raised to 2 into 0.1104. Okay, so this comes to 0.167. Similarly, you have to do for rest of the cash flows as well. So for the second one, it will be um, second one is 2 into, so this will be 2 into 2 plus 1 divided by 1 plus 15 percentage. This is, yeah, this is right only. Yeah, 15 percentage raised to 2. Okay, it will be raised to 2 only, into, now the second one weight is 8.31 divided by 86.59. 8.31 divided by 86.59. So that comes to 0.436. Okay, then the third one, it will be 3 into 3 plus 1 divided by 1 plus 15 percentage raised to 2 into, so third one it is 7.23 by 85 86.58, 7.23 by 86.59. So that comes to, third one is 0.758. Okay, similarly fourth one will be 4 plus 1 divided by 1 plus 15 percentage raised to 2 into fourth one 6.28. So 6.28 divided by 86.59. So that comes to 1.104. And fifth one 5 into 5 plus 1 divided by 1 plus 15 percentage raised to 2 into, so it was 55.18, 55.18 divided by 86.59. So this comes to 14.45. Now when you add up all this, okay, when you add up all this, it will come to 16.92, which matches with the convexity, total convexity. So this is the total convexity, and what we have done is year wise, convexity here, based on the cash flow, year wise convexity. Okay, then the next one is change in bond price. So change in bond price is equal to, the formula is duration into delta YTM. So here I am assuming if the interest rate is going down, then it is duration into delta YTM plus half of, you can write half, or you can say 0.5. Okay, so why we are taking half is because in the convexity now, the interest rate will either go up or down, both will not happen, right? So that's why in the convexity we are just going to take one part, that's why half, either upper one or the lower one. So that's why we are taking half. Okay, so depending upon the questions. Okay, so half into convexity into delta YTM square, as it is the second derivative. Okay, so you take a half or else you take 0.5. But suppose if the question says like the interest rate is going up, then you should change this to minus. That's the only change you have to do. In case if they say that the interest rate is going up, then you should do like this. Otherwise, if they say the interest rate is going down, then you don't have to make any changes here. Okay, so yeah, so right now you don't need this one. Okay, this is just duration right now. So because in this case I am going to assume that the interest rate is going down. So if the interest rate is going down by, so let's say if interest rate goes down by 50 basis points, then what will be the change in price? So then change in price will be, change in bond price is going to be, duration is, we have calculated duration 3 point, yeah, duration is 3.5. Yeah, So 3.5 into delta YTM is 0.05 plus half of convexity is 16.92, okay, into 0.005 square. So this is one group, this I can take as another group, and then when I add, okay, I will get 0.017711, okay, which I will convert it into percentage. It will be 1.7711 percentage. Okay, so this is the change in percentage. I can write this as percentage change in bond price. So yeah, this will be better. Percentage change in bond price. Okay, so that heading I should give. Percentage change in bond price. Okay, and so the new price of the bond is equal to, earlier it was 86.59, correct? 86.59 earlier, right? So earlier it was 86.59, that's the present value. Right here also 86.59, so present value. Now bond is changing by plus 1.7711 percentage. So when you add this percentage, it will reach to 88.125. So this is the new price of the bond. Now if I want to calculate money duration is equal to duration, okay, duration into, so money duration means overall change in the value of the portfolio, okay, portfolio of bonds, overall change. Duration is change in the bond price for 1% change in the interest rate, and money duration is overall change in the value of the portfolio, okay, for 1% change in the interest rate. So that is money duration. Okay, it's like change, entire change in the value of the portfolio. So duration into full price of the bond, okay, into number of bonds, because full price of the bond as in for one bond, okay, into number of bonds, okay, into number of bonds. So say for example, in this case, imagine you have bonds whose par value is $10 million, okay, and total par value is $10 million, and par value of each bond, so bonds whose total par value is $10 million, par value of each bond is equal to 100, let's say $100. So this is the case, and yeah, so right now full price is, let's say 86 point, so I'll go with the previous number we have calculated, that is the base case, okay, 86.59, correct, 86.59. So I'll take that as the base case. So here money duration now is equal to duration is 86.59, sorry, duration was 3.50 into full price 86.59. Now into, I need to calculate number of bonds. So number of bonds, how will I calculate? Number of bonds is equal to $10 million divided by $100. So $10 million divided by 100. So that will give me uh, So that will give me, yeah, 100,000 bonds. So number of bonds is equal to 100,000. So I'll multiply by 100,000. So that will give me 30,30,6,500. So this is the money duration. Okay, so total change. Now convexity also, money convexity. So total money convexity. Money convexity is equal to money convexity as in overall convexity of the entire portfolio. So convexity into full price of the bond into number of bonds. So convexity is, we know it is 16.916, correct? We found out here 16.9 or 92, let's say 16.92. So 16.92 into full price is 86.59. Okay, 86.59, it's mentioned here, into 100,000 bonds. So that comes to 16.92 into 86.59 into 100,000. So 1465, 1465, 10280, 1465, 10280. Yeah. So this is the convexity. Fine. And the new price of the portfolio is supposed to be then new price, or before that I'll say change, okay, change in bond price, change in bond price for the entire portfolio. For the entire portfolio is equal to money duration into delta YTM, okay, plus half of, so half of money convexity, total convexity, okay, that is money convexity into delta YTM square. Okay, so if you notice, this formula is, just what I have taken from this one, this part. Okay, so money duration is 30306500. So 30306500 into 0.005. So this is one group, plus half of money convexity is 1465 10280 into 0.005 square. So this is second group. Okay, so overall it comes to 30306500 into 0.005. So which is 151532.5 plus uh, So the second one is 183 1. Okay, 0.3785. So this comes to 153363 153363.8785. Okay, so now new price will be uh, so initially 86.59, and we had 100,000 bonds. So initially it was 8659 triple zero 86.59 into, yeah, 8659 triple zero. Now this was the initial price. So along with this I will add, so this is the old price. Now I will add plus 153363.8785, this number, plus 153363.8785. Okay, so yeah, so this comes to 8812,363.879. Okay, 8812, yeah, 363.879. This is the new price. Okay, yeah, fine. So I think I have covered um, all these terminologies: money duration, Macaulay duration, modified duration, effective duration, convexity, money duration, money convexity, change in bond price, and convexity based on cash flows. All right. Okay. So I hope it helps you. Thank you so much for your time. Thanks a lot.